Hello everyone, good evening wherever you're watching from, or good morning. The time is 8 o'clock Nigerian time, that's GMT plus 1. Alright, I welcome you all to this session. I hope at the end of today we're going to learn a lot. Okay, I'm so glad speaking to engineers of like-minded today, and of course this session is actually an interactive session. So if you have any question at all, just do well to drop it on the live chat, which is by the right hand side on your screen. Okay, so my name is Lawrence Okegbemi, and I'm a machine learning engineer. I love building intelligent systems. One of the things that actually fascinated me and brought me to engineering is robotics. Yeah, so that actually spoiled my interest into building intelligent systems. Yeah, sorry about that. I think I had an internet issue from here. So do well to drop any question you are having as regards anything I will be talking about. I will attend to it. I will do well to attend to most of your questions today. Okay. Start preparing your question even as we go through the for today. Okay. Let's start the session proper. Okay, so today we are dealing with building intelligent systems, its application to mechanical engineering. All right, my name is Lawrence Okegbemi. For those who don't know me, I'm a machine learning engineer, and I'm also the AI Plus DSN lead for Federal University of Technology, correct? At the same time, I'm a mechanical engineering student, and I'm proud to say I'm part of the NIMEK executives. I'm technical secretary for the National Student Forum body. Okay, here is my social handle at Lawrence Bolo on Twitter, and of course you can also link up with me on LinkedIn. All right. So, what is artificial intelligence? The buzzword nowadays, everyone is hearing artificial intelligence here and there. People want to know what artificial intelligence is. What is it all about? Artificial intelligence is common. People have been looking at, is it that one kind of robot that want to wipe us away from the surface of the earth, or what is happening? Artificial intelligence here and there. And it's just a simple definition for artificial intelligence. AI is the science and engineering of making smart and intelligent machines capable of performing tasks that typically requires human intelligence. A lot of people have been asking several questions about artificial intelligence. Is it that it will take away a lot of jobs? Will it provide a lot of jobs? What are the benefits? A lot of questions have been arising around artificial intelligence. But I must tell you that artificial intelligence is something that we really revolutionize. Of course, it's already doing that, but there are still a lot of impact that artificial intelligence will make in our world today, and engineering as a field is no exception. All right, so we have machine learning, we have AI. At the same time, I just want to define some concept for us here before we actually go in depth, because some of these concepts people mistakenly take them for one another, and it is very important that I do good justice to it before we actually move on. Okay, so what is I've defined artificial intelligence, and now I just want to define what machine learning is. Machine learning at its most basic is the practice of using algorithms to pass data, learn from it, and then make a determination or prediction about something in the world, like in the real world. Yeah, this definition was actually given by NVIDIA. NVIDIA is a company that produces hardware and compute resources. Okay, so machine learning, what you are doing when you're saying you are doing machine learning is that you are taking data, then you are building some algorithm, you feed that data into the algorithm. The algorithm will learn the patterns, or will learn more about the data, will read the data, will understand everything that has to do with the data, and at the end you will be able to actually ask the machine or the algorithm which you've built to make some predictions for you, and to do that appropriately. It will do that for you easily. That is machine learning. So it's just like your machine is learning from data. That is machine learning purely. And as we go on, you will see how machine learning relates to artificial intelligence. They are together. No one is leaving the other. They are together. So basically, machine learning, or let me recap again. Machine learning is, you are giving your machine, or you're giving your algorithm, in this case, that's what I mean by machine. Your algorithm is learning data, is learning from data. You are learning several patterns, you are learning quite a lot of stuff from the data in order to make predictions, or in order to make some act, or to perform some actions that are based on the data which you've learned before. All right, so the next one is deep learning. I know you must deep learning here and there, deep learning here and there. Okay, for those in engineering, some people might not have heard of deep learning before, but deep learning basically involves building computer algorithm that simulates the network of neurons in the brain. Please, if this is too kind of complex for you, I don't mind. I can do a recap just for you to get what I'm saying. Just drop it on the live chat. I will go through it. Okay. Oh, all right, guys. Welcome everyone. Yeah. So, what deep learning actually is, it involves building computer algorithms that simulate the network neurons in the brain. That's what deep learning actually is. If you look at this, the image beside here, you see cat and dog. Now, what you do when you say you're doing deep learning, or what you're doing involves deep learning, is that, look at this these neurons here, like these layers here. You will pass these cat and dog images into these layers, and at the end of the day, it will give you an output, whether it is a dog or it's a cat. That is deep learning. So in deep learning, what you are doing is you are building a kind of interconnected neurons. That's what we call it. We call it interconnected neurons, or networks, yeah, that can make predictions for you. Okay, that's deep learning. It's just imitates the human brain. That is the way you have your brain configured. That's what it does. That's what you mean by deep learning. So everything, you have neurons, you have the perceptrons, you have everything. So this is a perceptron, this is a perceptron, this is a perceptron, and everything here, this theory, you call it what we call multi-layer perceptron. Okay, you call this multi-layer. This is a perceptron, this is a perceptron. It's just biological. The idea of deep learning was actually gotten from biological interpretation, or from biological sides of things. So that is how the brain works exactly. If you want to know how the brain works, when you consider deep learning, you actually see how the brain works. If you consider deep learning, you will get to know how the brain works. So the brain works through interconnected neurons, and through that you are able to build a computer algorithm that is able to recognize between a cat and a dog. This has a lot of applications nowadays. A lot of applications. It can classify. We can build a deep learning algorithm to classify several things for you. as well as skin cancers. A lot of people are actually using deep learning for skin cancer detection. We have a company, a retina based company, that uses deep learning to diagnose eye defect, or that is to diagnose eye defect. So we have quite a lot of applications of deep learning nowadays in the industry. Okay, and engineering is of no exception. As we will see later on, you have several companies that are actually using deep learning to do pattern recognition, to do quite a lot of stuff. Okay, so let's now discuss about how the three of them relate to one another. Okay, so let's look at how the three, or the machine learning, deep learning, and artificial intelligence, let's look at how they actually relate to each other, because when you understand this properly, it will enable you to know the right term to use at one point or the other, or the appropriate to actually look out to. Okay, so artificial intelligence, when I gave the definition of artificial intelligence, I actually said AI is the science and engineering of making smart and intelligent machines capable of performing tasks that typically requires human intelligence. So instead of having human perform the same task every day, you can actually build an AI agent that will perform that task instead of having human to perform that task. Since it's a repetitive task, definitely your agent, that is your intelligence agent, can actually learn from successive trainings and perform the same task. Okay, the difference between the both of the three, which I've explained, artificial intelligence, machine learning, and deep learning, is that they are all subset of one another. Deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. All right, so I'm just checking out our charts. I want to see those who are actually commenting. Oh, it's cool. So artificial intelligence is a technique which enables machines to mimic human brain or human behavior. Okay, as you can call it, human behavior. All right, and machine learning actually is a subset. Yeah, just like what I'm saying, it's a subset of AI technique, which is statistical methods. You make use of a lot of statistical methods in machine learning to enable machines to improve with experience. So your machine, your algorithm will actually get a lot of experience, and from that experience it will be able to predict or make some decisions right from the data it has learned from. All right, so and deep learning, which is like let me say, like the subset of the subset of AI, in quote, pardon me to use that word, a subset of machine learning which make the computation of multi-layer neural network feasible. All right, so when you understand this chart, when you look at this chart appropriately, you will know that machine learning is not different from deep learning, and is not different from artificial intelligence. So the three of them are actually interwoven. And the main thing about deep learning, which I want you to understand, or I want you to take away from here, is that deep learning mimics the human brain because it has the network has interconnected neurons that it typically just mimic the human brain. All right, so that's what I want to say about artificial intelligence, machine learning, and deep learning. And now let's look at the various applications of machine learning in the industry. It has a lot of applications nowadays in the industry. Okay, including automatic translation, which you can see here. Automatic translation, now we have your Google Translate. Your Google Translate does quite a lot of stuff for you. You can translate from any language, probably from English to Hausa, from Hausa to Japanese, from Japanese to Chinese. You have quite a lot of language. So automatic translation is one of the current implementation of machine learning. All right, now okay, let me use these what I have here, self-driving cars. Okay, you've been hearing about self-driving cars here and there. I'm sure quite a lot of people have heard about Google's self-driving cars. You've heard about Tesla. You've heard about several other probably Lyft or Uber. A lot of these guys are using self-driving cars nowadays, and as you see later on, that self-driving cars, what enables them to do this is just the augmentation of your normal vehicle with artificial intelligence. That's what makes self-driving cars. We have Tesla autopilot, as I'm going to show you later on. They are just your normal vehicle running normal. It can be running on internal combustion engine. Not really, no, it's not really common, but then most of them don't really run on internal combustion engines. They don't really run on that because of power issue. But what I'm just trying to drive at here is that artificial intelligence, when it comes to the recognition of objects, how the vehicle navigates, a lot of stuff like that, it involves artificial intelligence, and you use deep learning here most of the time. Now in the health industries, just like I made mention when I was explaining the company that makes use of deep learning to diagnose the retina. So if anyone is having eye defects, they can quickly diagnose it using their deep learning algorithm which they've built. And of course, we have a lot of cutting edge research that involves detecting skin cancer. All right, so we have Snapchat applications. Now Snapchat application include if you, for a lot of people who uses Snapchat very well, you see that it can position all this effect appropriately, like your tongue, your face, putting on some probably all this cat effect and some stuff like that. You see that it's actually artificial intelligence. It's just recognition, like facial recognition. That's all it is. So it's actually an artificial intelligence application. Now we have facial recognition. A lot of systems nowadays, even when you build home automation systems, a lot of people are actually using facial recognition. In some big organizations, you have people using using facial recognition for their staffs. In order for you to gain entry into the building, gain entry into their facility, you need to do some stuff like facial recognition. Okay, and all these things you can actually transfer them into any system you are building. Like, or when I mean any system, probably it can even be your project, like your mechanical engineering project. You put facial recognition, like, okay, for this machine to be able to operate, there are certain faces it needs to see, and of course that is very, very important when you are considering security. So facial recognition is one of the key applications of machine learning, or the implementation of machine learning we have nowadays in crime investigations, in robotics. You will see later on that it has really significantly improved robotics. When you're talking about artificial intelligence, you are not just talking about robots. Yeah, when you're talking about artificial intelligence, you're not talking about robots. Robotics is another field on its own. Even without artificial intelligence, you can do robotics without artificial intelligence. Just logics. Just give the system logics. Artificial intelligence is quite different from that. Artificial intelligence means you are developing an intelligent agent. Okay, yeah, that is an intelligent machine, something that can perform the task human being can perform, or that can reason the way human being will reason. That's artificial intelligence for you. Okay, so robotics, don't think robotics is artificial intelligence. No, robotics is not artificial intelligence, and artificial intelligence is not robotics. Okay, now we have speech recognition as well. We see a lot of speech for those of you that uses your Google Assistants. Quite a lot of people use Siri or Cortana. You use Amazon Alexa, or probably you are using IBM Watson conversational service. So you have a lot of speech recognition programs that runs. So what it does is that it takes your speech and convert it into words, or like convert it to words that can be processed, and later on give you back your response. You know, some people even use speech recognition for security nowadays, but then yeah, it's not really strong. Okay, we have self-automated machines like ATMs. All right, so I'm not going to really dwell much on that. Then we have traffic detection and weather forecasting. So for a lot of people in other disciplines of engineering, like civil engineering, that they deal with transportation. Now when you use machine learning in such a case, we actually see that you can reduce traffic congestions using machine learning. You can reduce that. It's just a network algorithm. So once you use that network algorithm, you will be able to actually design some what's it called, come up with a better or an optimized way of dealing with traffic. Your system can tell you if traffic will occur at this certain location at this time, or when is the best time for you to actually move on the road. So all these things are just artificial intelligence programs that can run. Okay, so the next one, which let's move to mechanical engineering. Let's talk about mechanical engineering let's talk about mechanical engineering for a while. All right, so when you talk about mechanical engineering, what do you mean? One thing is, I really love mechanical engineering. Yeah, and the reason is because, to me, mother of all engineering courses. Yeah. Okay, I'm saying this because I'm mechanical engineering what's it called, community anyway. So mechanical engineering is like mother of all engineering courses. All right. Oh, let me see if I'm saving. Okay. Oh, let's start recording. All right. Okay, so let's move on. Mechanical engineering has the ability to engineering disciplines, electrical engineering, civil engineering, agricultural engineering, metallurgical engineering, to mining engineering. Quite a lot of engineering discipline. Mechanical engineering fit into all of these things, and of course there are a lot of projects that even if you want to work on, you will always need a mechanical engineer. Yeah, quite a lot of projects that you need to work on, you need a mechanical engineer. And another reason is because they deal with almost everything all other engineering discipline deals with. You deal with materials, look for strength of materials. You deal with electrical machines. You deal with quite a lot of stuff, mining machines, a lot of things, with quite a lot of things. So that's how mechanical engineering is unique. And of course, mechanical engineering has a lot of ways to improve, especially with machine learning and artificial intelligence. Quite a lot. Okay, so let's look at the area of interest when you choose mechanical engineering before we actually dive into how you can use machine learning to improve quite a lot of areas, which I'm going to demonstrate to you today. Okay, so areas of interest. When someone picks machine learning, mechanical engineering, pardon me for that. When someone picks mechanical engineering as a course of study in higher institution, these are some of the areas. Not all. Not all. I just listed most of these important, like the common areas. Yeah, in mechanical engineering. So the first one is mechanical design. All right. A lot of guys now uses AutoCAD, SolidWorks, Pro-E, quite a lot of mechanical engineer CAD design softwares. So we have mechanical design. This is actually like the first, or let me say the second stage of every mechanical engineering project. You always want to design, like have something, or can design, okay, this is what we want our product to look like. Then we have fluid mechanics. Of course, fluid mechanics is really one of an area that's quite a lot of people are really interested in, but then in Nigeria, the application has not really grown, especially, let me say, in the aspect of artificial intelligence, how you use artificial intelligence in fluid mechanics. Yeah. Okay, so we have mechatronics and robotics. Mechatronics is not robotics. Okay, let me say that. People actually mistake the both most times. Mechatronics is not robotics. Mechatronics is just mechanical and electronics. When you have mechanical and electronics, of course, your robot actually contains of your mechanical part and your robotics part sometimes, but then mechatronics still have quite a lot of in-depth stuffs, which doesn't at times you will not say mechatronics is robotics, or robotics is mechatronics. All right, guys, are you following? Please, if you are not following, kindly state on the chat. I will be glad to attend to your questions. Okay. All right, so we have industrial engineering, industrial and production engineering, we have thermodynamics, we have automotive and aerospace engineering. Okay. Industrial and production engineering is another key areas in mechanical engineering, which every engineering project we always want to implement. Of course, when you have your project from design to go to production. Okay. I'm not talking about you. Of course, sometimes you have other processes in between design and production. All right, I'm just for the sake of this presentation. All right, then we have automotive and aerospace engineering. Okay, I'm sure quite a lot of you watch the SpaceX and the NASA program, or what's it called, live session that was last week Saturday. All right, it's quite interesting, and probably before the end of today I will tell you how these guys are really using artificial intelligence to optimize and build efficient systems. Of course, these are areas that really that when you have the skills of a mechanical engineer and also the skills of an AI engineer, that's an artificial intelligence engineer, when you combine both together in some of these organizations, or in some of these what's it called, in some of these organizations or industries, it will gives you an edge. It will give you an edge. Yeah, it will give you an edge. Aside from other anybody who just knows fluid mechanics without AI. Yeah, one thing about AI is when you apply AI to any field, it gives you what called competitive advantage. So you have competitive advantage even amidst your peers. All right. So now let's talk about the first application which I would like to enlighten you on: self-driving car. Okay, some years ago, or let me say like 2 years ago, Tesla began to gain popularity. Okay, Tesla began to popularity, and of course you have the Google car too, but Tesla has really made a tremendous effort in building an efficient system. Okay, what do I mean? I'm not saying Google is not building an efficient system, don't get me wrong. I'm just saying I'm using Tesla here as a case study only. So we have something called the autopilot in Tesla. How does the autopilot works? Now, as a vehicle engineer in school, probably your 500 level or your final year, perhaps some people use 4 years to study mechanical engineering. I'm sure you actually know about vehicle engineering, and some may actually term it as automotive engineering. It depends on your university. All right, so you have, after building a vehicle, or let me just say an automobile, or an automobile now, then you want to incorporate artificial intelligence into it. Where do you start from? Now, if you look at this left pane beside this picture, you will see some things like left awarded vehicle camera. Now, all these cameras are positioned in the vehicle to capture images. Now, these images are being processed in real time. All right, they are being processed in real time. And what do they use? They use just deep learning. Yeah, they use deep learning. The AI director, the senior AI director at Tesla, Andrew Chikepati, during one of his presentations, they use deep learning, and to train this system sometimes takes like let me say years. Let me year, like if you train on just a single compute, like a single computer, it can take a year to train this artificial intelligence model that can that can actually recognize all these images in real time. All right, now why do you just need to make all these kind of cars autopilot? Why do you need all these things? Okay, first of all is it reduces traffic congestions, because a lot of cars will be able to navigate and knows they have this dashboard. When you look at this Tesla, you see that you have this navigation and GPRS dashboard here, or like this screen here. The screen can actually tell an optimized route for the vehicle to take to its destination. Here are some of the applications of artificial intelligence. So not just building or designing an automobile. If you use artificial intelligence, of course, you make it more effective and more robust. Okay, now when you look at here are some of the things to note. Anyway, here are some of the things to note as regards self-driving cars. Now they have advanced GPRS and navigation system. Okay, look at this road. When you look at this road, as clumsy as this is actually more or less like a roundabout. When you look at this roundabout, you can see that these cars are moving appropriately. All these cars, they are all self-driving cars, and you can see that they are moving without actually affecting one another. Okay, they are moving without affecting one another. So it is because they have advanced GPRS and navigation system. That's all. Now some of these cars make use of something we call reinforcement learning. I didn't explain reinforcement learning earlier. Reinforcement learning is a set of machine learning too. Is a technique whereby you or it involves building agents, artificial intelligence agents that can learn from experience, or some of them learn from experience or learn in order to maximize reward. You may not get that, but then what they do is just like a newborn babe. When you give birth to a newborn baby, you don't expect the babe to know how to brush or to know how to take his or her bath. But as time goes on, the baby begins to learn all of those things. That's basically what you do in reinforcement learning. You train a machine, a computer, to be able to perform a task very well. So sometimes before this, they actually make all these cars available on the streets. Some of them through a simulation environment, they will have trained them. The car will have crashed several times in order for it to learn how to actually balance itself on the road. Yes, they do all of those things through a simulation, like through an environment that is a virtual environment, in order to train some of these cars. So that's just what reinforcement learning means. And most of them does not use internal combustion engine. And this is why I want to say to engineers that don't just rely on the old systems. I'm not saying internal combustion engines are not good. Of course, they have their where they are actually good. When you are dealing with heavy trucks, or you are dealing with some complex systems, they are very, very good. But when it comes to building more optimized products nowadays, or products that really thrive in years to come, you need to actually look for alternatives. Sometimes some of these cars, instead of using internal combustion engine, they rely basically on another source of power. Some of them rely basically on another source of power. Okay, so most of them doesn't really use internal combustion engine. All right, so let's go to smart maintenance. How AI is used in smart maintenance in order to improve and reduce the maintenance cycle. All right, so okay, let me check. Is there any question? If you have any question, please drop it. Okay. All right, guys. I'm coming. I will attend to most of your questions. Yeah, don't worry. I'll attend to most of your questions. Okay. So we have smart maintenance, and AI is really used in maintenance. Hope you all know that maintenance is an area, or is more or less like a branch in mechanical engineering. It's one of the things mechanical engineers does. Maintenance. You do maintenance a lot in several industry maintenance. All right, so the first thing I want to mention about maintenance is or how you can use AI in maintenance is fault detection and diagnosis. Fault detection and diagnosis. With artificial intelligence, easy for you to detect faults in systems. It's very, very easy for you to detect faults in systems. Very, very easy, and for you to diagnose fault in systems. Imagine you built a very complex machine, and it needs to be monitored and maintained regularly, or probably you have to come and do a daily check. Okay, with artificial intelligence, when you put artificial intelligence in such a system, you can always get a report. It can even be a daily report. Instead of you coming down to the factory every time, you can actually build a machine learning system, attach it to the or just ensure that you fit it into the machine, then it gives you daily report. Or whenever there is whenever a particular part is wearing out, or whenever there is overheating, things like that are what you can do with artificial intelligence. Okay, and I'm going to show you some of them later on, because some people will feel like I can do this with just sensors. Okay, yeah, fine, you can do it with sensors, but when it comes to fault detection, some faults can always look similar to several well, if you work with some kind of machines, you will actually understand what I'm talking about. That it's not actually easy to detect faults. Sometimes you have to check several places, but with artificial intelligence, it's easy for you to know the exact part or the exact place that is actually having an issue. All right, so here are some of the techniques you use in fault detection and diagnosis. One of them is pattern recognition. When I'm talking about pattern recognition, for instance, you can have you can have a kind of, probably you are working on your lathe machine now. Let me use for example, you are working on your lathe machine, and you realize the pattern you have on your on the tool you are working on. Now, such pattern, when you take the picture, let me just use for example, when you take the picture probably with your iPhone, and you send it to a model which you built. Now that model can actually tell you how well to probably improve in that machining process. It can tell you how well to improve in that machining process, or you can even build a kind of system to tell you whether the cutting tool you are using on your lathe machine is okay, whether it's appropriate for that task or is not appropriate. So these are some of the things you can do under pattern recognition. All right, another another application is predictive analytics. Okay, in maintenance, most times you can with the aid of artificial intelligence, you can always predict when next fault will occur. Now let me use an electrical system for an example. Okay, so after collecting several data, like heat, collecting probably oil level in a transformer, collecting the heat data, collecting quite a lot of data like that, how well the transformer is running. After you've collected all of this data, you can actually use the data to build a model, an artificial intelligence system that will predict if the transformer will have fault or not. Now I'm using a transformer as a case study, just might be different. You might want to do it in other places, but one thing is very, very important here. It is the data you are getting that is most important here. Sometimes, the data you are getting, because if you don't have data, it may not be possible. Let me say it may not be possible. In most cases, it may not be possible for you to actually do something called predictive analytics. If you don't have data, there is nothing you can do. So first of all, you need to collect data. So it is the data that you've collected that will actually guide you into, or that will help you to build a system that can forecast or that can predict when such system you are working on, or the system you are monitoring or you are maintaining, whether it will develop a fault or not. Okay, so you also use it for optimization. One thing about maintenance is maintenance consumes quite a lot of time. a lot of cycle, especially as I'm going to show you later on in aircraft maintenance. Aircraft maintenance is very, very difficult because you have to be patient. It has to undergo series of maintenance before you actually fly such an airplane. Okay, so there is need for you to there is need for you to put AI in some of these systems in order to optimize the cycle, in order for you to optimize the cycle. So another thing that this is one of another benefit AI gives to like mechanical systems. Okay, to optimize, it helps us to optimize the system to perform better after collecting series of data. Then it can maps, like I'm talking about your artificial intelligence model now. Then it can maps for you. Okay, this is how it can optimize the system for you, like the optimized process. Okay, all right. So next one is in automobile. How is artificial intelligence used in automobile? So you have there is a software that all this I know a lot of diagnostics companies use different tools to diagnose cars. Okay, but one advantage artificial intelligence have in maintenance of automobile is that AI can help to reduce downtime. Now what do I mean by that? Your system already knows, or let me say your vehicle rather, your vehicle already, when you integrate artificial intelligence into your vehicle can tell you, okay, this is what is going on with this vehicle. And this is made even simpler when you are working with a smart vehicle. Yeah, when you're working with a smart vehicle like an autonomous vehicle, all of these diagnostic tools are really implemented in the system. So AI can help you to reduce downtime. It can forecast. You're having the brake system is having an issue, and you should actually take it back to a technician. These are some of the things that you can actually use artificial intelligence for. Your artificial intelligence can actually collect your car data, like probably the places that your car has been to, the speed at which it has actually gone for, and tell you how long the car can still, actually sustain before it breaks down. Okay, here are some of the things you can do with artificial intelligence. Okay, now the next one is aircraft maintenance. There are actually a lot of companies using artificial intelligence to maintain aircraft nowadays, especially all these aircraft engineering companies. All right, now AI can help to improve fuel efficiency. One of the major problems they have in the aviation sector, especially in the aircraft part, is that aircraft consumes a lot of fuel, especially at takeoff time. It consumes quite a lot of fuel. Now when you have this system, when you have artificial intelligence in this system, it can actually help you to develop a profile that will be optimized, then tell how best to move. Now what do I mean? When an airplane, let me use an airplane now, is very common to us. Now let me use an airplane. When an airplane is about to move, the time it consumes more fuel is the time it's taking off. They call it like the climbing phase. Now during that climbing phase, if you can collect series of data of how climbing phase has been occurring, and climbing phase is actually the only the most part that consumes fuel. So if you can collect different data from the climbing phase, then we can actually do a kind of optimization in order to reduce the fuel consumption. All right, so that's what we can use AI to do with aircraft. And at the same time, in the maintenance, we can use AI to diagnose several parts of the aircraft. What is happening to this part? Will this part get fault? If yes, what are the remedies? Like what can we do to actually improve the system before we put the airplane in the sky? All right, so here are some of the things you can do with artificial intelligence. So then we have autonomous drone for pipeline maintenance. Okay, yeah, someone is asking, yeah, you can get the I will share the slide with you soon. All right, so autonomous drone for pipeline maintenance. This has been existing for several time for a very long time now. So yeah, like for some years ago now. Autonomous drone for pipeline maintenance. Now you can have a pipeline running from Lokoja down to probably Borno, using that as a case study. So how do you want to send out the maintenance team to always keep checking on the pipeline, whether there is no leakage, whether all these guys who breaks pipeline have not vandalized the pipeline? So you can actually have a drone. It's an autonomous drone. The drone knows when it should take off. The drone knows where exactly to check. It knows the location of the pipeline to check. Okay, so you can use autonomous drone for pipeline maintenance. All right, you can use it for pipeline maintenance to check if the pipeline is faulty, if there's tendency of the pipeline to actually get vandalized, probably is rusting already. So these are some of the things you can do with drones. Okay, and these drones are autonomous. It's not that someone is controlling them. They are autonomous, like fully autonomous. They are working on their own. They have no external control. They are not being controlled by human. They only go to check once you deploy those drones. They go straight away to check for you whether your pipeline is faulty or is in good condition. All right, so let's talk about computational fluid dynamics. Computational fluid dynamics. This area, I know quite a lot of people doesn't really have much experience on computational fluid dynamics. All right, so I'm going to explain computational fluid dynamics. Tools actually combines numerical analysis, that is the tools you use in computational fluid dynamics. They combine numerical analysis and algorithms to solve fluid flows problem. They are used to model fluid density, velocity, pressure, temperature, and chemical concentration in relation to time and space. Yeah, a lot of guys who are really interested in fluid mechanics, you should know about computational fluid dynamics. It's an area that is an interesting area in mechanical engineering. Very, very interesting, and there are a lot of applications of artificial intelligence that you can use to actually improve this system. Okay. So go back to the computational fluid dynamics. You can use artificial intelligence to solve some complex problems in computational fluid dynamics. Actually, it's beyond the scope of this session, but then I would really like to introduce to it. So probably you are trying to solve Boltzmann. You can have a Boltzmann equation to solve. You can actually, instead of using your traditional solvers to solve it, you can have an AI system that helps you to optimize the process, like the process of solving the problem, and also gives you an answer in the shortest time. Yeah, in the shortest time. Because one of the things you want to do is you want to minimize time, like you want to minimize the way or the process. We want to optimize it rather. To optimize the process. So artificial intelligence comes into optimization when it comes to computational fluid dynamics. It can solve complex problems for you easily and without consuming much time. Alright. So typical application of AI, we have weather simulations. This is still in aerodynamic characteristics modeling and optimization. And we have petroleum mass flow rate assessment. Yeah, here are typical applications of artificial intelligence in computational fluid dynamics. We have weather simulations, aerodynamics, characteristics modeling and optimization, petroleum mass flow rate assessment. Okay. Then we have AI powered simulation. I'm sure some of you are really familiar with this Autodesk simulation. So when you start from here, will it fail? How will failure occur? How do parts interact? How strong does it needs to be? How light can I blah 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 blah. Now look at this cycle. This cycle is quite interesting. Yeah, it's quite interesting because look at everything is putting into consideration. But when you have a reinforcement learning environment, you can have a reinforcement learning environment that is an environment to perform your simulations. All of these things, just cases, like when I mean various cases, it will help you to test for several parameters in the system. Okay, like just beyond your normal classical simulation, your AI has the enablement to be able to perform several simulations for you within shortest time, and it will give you an optimized result. So you are not just getting results based on your parameters only, you are getting results based on the AI tool. So you are getting results based on several iterations. Okay, and of course you can subject this simulation to different environments sometimes with the aid of these some AI environment. Okay, so one of the AI environments which I'm talking about is provided by Unity. Unity is an is actually a company that produces AI simulation environment for if you want to perform anything that has to do with simulation in artificial intelligence. Sometimes you use you use Unity. Of course you can also use your MATLAB too, as they're going to see later on that MATLAB is a very important tool for engineers at the same time. Okay, so we have generative designs. Yeah, let me see. Okay, we have generative design. Yeah, this thing is very interesting, and I want you guys to actually listen here. Okay, generative designs, this is one of the cutting edge improvements in design nowadays, in car designs. Yeah, so what is generative design? Generative design uses computational algorithms and artificial intelligence to rapidly explore nearly infinite design options for any given product, bringing new automation to computer aided design. All right, now okay, so let me quickly show you part of things generative designs can do for you. If you look at this car chassis here, this is actually it's actually a generated image. Yeah, it was generated by the generative model. Now okay, for some of you who doesn't know what generative design is I think it's now been, if you know Fusion 360, Autodesk Fusion 360 have a section for generative design. What you do in generative design is you give series of images to your model, and at the end of the day your model comes up with several designs, like unique designs. Okay, look at this. Now when you look at this, we are trying to actually build the same thing, but look at the different designs you are having. Yeah, that's what generative models can do for you. Generative models are used in bringing out fake images. Yeah, fake images. A lot of fake images out there are based on generative models. Yeah, generative models actually generate some of these fake images you see out there. Probably if you've seen Obama speaking Yoruba before. Oh, you've not seen that? Yeah, Obama speaking Yoruba is actually it was generated. Yeah, everything works on the same concept, and with the help of additive manufacturing nowadays, there's a good combination between generative designs and additive manufacturing, because additive manufacturing can help you to bring out complex shapes. Like after generating some complex shapes via your generative design frameworks or in any application you are using, you can actually transfer them to the format that you use for your 3D printers or anything. Then you'll be able to bring out the design, you'll be able to bring out whatever you've modeled, okay, or whatever you've produced through your generative design. All right, so generative design is actually new. I think SolidWorks 2022 has it, but I'm not sure. Yeah, I'm not sure. So this concept is made possible using generative models, like this concept you are seeing here, some of which are developed using adversarial networks. Example of products using generative designs include Autodesk Fusion 360, Siemens NX, etc. We have quite a lot of some like new products nowadays are using generative design. This will really revolutionize or will really improve the way we do CAD, right? Computer aided design. This will really improve the way we do computer aided designs. All right. So let me show you generative adversarial network. Now, one thing I want you to know is that mechanical engineers have this advantage because you've done quite a lot of mathematics. It's very easy. It's very easy for you to jump into artificial intelligence and make quite a lot of interesting stuff. You do quite a lot of interesting stuff. Yeah, the reason is because all of these things, they work based on just the chunks of mathematics. Yeah, mathematics basically. Now look at this generative adversarial network. This is what is used. This framework we are looking at here is what is used to produce all these generative designs. Yeah, all these generative designs. This is the framework that they use. It is called an adversarial network sometimes. So here you have two networks. You have the generator and you have the discriminator. The generator is the one generating the fake images. The discriminator is the one telling the generator that the images you've produced is still fake. So the generator will now generate. It will look at the image again, perform better, like it will improve on the images that's generated initially, then give it back to the discriminator. The discriminator will say this is a real image or a fake image. All right, so the cycle continues like that, and that's how you see that when you are generating fake images, most of them looks quite similar. All right, yeah, they look quite similar most of the time. Okay, so robotics. Yeah, let's move down to like the last part, which is actually interesting. Yeah, robotics. So I said earlier, robotics is not artificial intelligence, and artificial intelligence is not robotics. So yeah, and we're going to run it up soon. How will AI help robotics, or how is AI helping robotics right now? Okay, let's look at some applications. Yeah, we have some applications like vision. Okay, AI is helping robots detect items they've never seen before and recognize objects with far greater details. Yeah, so in vision, I will show you later on how Amazon is using this. We have grasping. Robots are also grasping items they've never seen before with AI and machine learning, helping them determine the best position and orientation to grasp an object. All of these things are not possible with classical, like with traditional robots. Traditional robots doesn't really have the ability to do all of these things effectively. But when they are actually, when AI is integrated into the system, it makes the system more efficient and to be able to perform all of these tasks easily. Okay, we have motion control as well. Machine learning helps robots with dynamic interactions and obstacle avoiding or avoidance to maintain productivity rather. Okay, so when it comes to motion, I don't know if anyone has seen this Boston Dynamics what's it called, robot before, that can do backflip. Yeah, it's really performing a lot of stunts. Okay, yeah, that's an example of an AI system. Although later on those guys actually said it was just logics. It wasn't really artificial intelligence, it was just logics. But then it's actually an improvement. I'm quite sure most of the things they used to build that system was some techniques from artificial intelligence. All right, then we have data. AI and machine learning both help robots understand physical and logistical data patterns to be proactive and act accordingly. Okay, so when you look at your self-driving cars, just as we discussed, they gather a lot of data in order to improve their performance. So same thing with robots. Robots gather a lot of gather quite a lot of data in order to improve their experience. If you can watch this video here, you will understand other applications of AI in robotics. Yeah, you can just copy out this link. Okay, so here is how Amazon is using artificial intelligence. So look at this Amazon robot. When you go to Amazon warehouse, all these robots is actually able to carry this large load from one location to the other. And there are quite a lot of these robots in Amazon warehouse. Quite a lot of these robots. What do they do? These robots have sensors, they have camera, they have they knows where they have good navigation system to be able to move from one location to the other. They don't eat one another. Of course, you can see that they are carrying luggages. Now, all of these robots, people are designing them, right? And mechanical engineers actually have an edge in designing all of these systems, honestly. All right, so that's how Amazon is using robots in their warehouse. If you go online on YouTube, you actually see quite a lot of their images, quite a lot of their videos, how all these robots actually operate in their warehouse. All right, so here are some of the tools. We've actually come to the end. Here are some of the tools that you should actually get in your toolbox. Okay, the first one is I would really encourage engineers, like mechanical engineers especially, learn some of these tools that are here. Of course, other engineers too can learn it. Yeah, learn some of them. For instance, learn C++, learn Python, MATLAB, be good. Of course, your CAD, don't take your CAD for granted. It's very, very important for every engineer or mechanical engineer to know how to design, even if not up to a good level, but at least you should know how to do that. Then you should learn TensorFlow. Now, PyTorch, the Tesla autopilot I showed you initially, they are actually using PyTorch. Yeah, you should learn this. Of course, ROS, this is robotic operating system. Now, this PyTorch and TensorFlow are Python frameworks. Of course, PyTorch now supports C++ too. C++ is really good. It's faster than Python and is more efficient and more compatible with when you are dealing with hardware like embedded systems, or you are dealing with electronics. You can use your C++. It's very, very fast. Python is good for prototyping, and of course your MATLAB is good for matrix computations. Quite a lot of computations you use your MATLAB for. It's very, very good. Okay, yeah, I would really advise you to learn some of all these tools. Okay guys, yeah, you should learn some of them. It's very, very important. If you want to jump into AI, you want to get started, you need to learn some of these tools that are here in order for you to do probably image recognition, computer vision, or do quite a lot of probably natural language processing or some stuff like that. You need to learn some of these tools. You need to know how to make use of them. PyTorch or TensorFlow, Python, or this, a lot of implementations of image processing now are being done with MATLAB. You get. All right. So you can check out some of these links that are here, and we've actually come to the end of today's webinar. I want to attend to your questions. Okay, I want to attend to your questions. Okay, let me share my slide with you guys. Okay, so ask your questions. I'll be expecting your questions, guys. If you have any question, and in case you need to reach out to me, just send me an email. Yeah, just send me an email. So I will drop my mail, or probably hook up with me on LinkedIn or on the on Twitter. All right. So, I think my network is quite bad. Yeah, I will share the slide with you. Yeah, I will share the slide with you guys. Okay. Yeah, I will share this slide with you guys. Okay. Okay guys, I'm still expecting your questions. And if you don't have any question again, so I think we'll have to call it a day.
I will share this slide with you guys.